Well, good afternoon, good evening, or good morning, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you missed any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, any of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are going to be doing a drawing for 4 $100 Amazon gift cards. So please stick around. Hopefully you will be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Federator.ai for optimizing resource management on OpenShift. Our speakers today are Sunny Su, who is a co-founder of ProfitStore and president, Ming Xu, who is the Executive Vice President of Product at ProfitStore, and Cody Richard, who's a Global Partner Solutions Architect at Red Hat. Welcome, gentlemen. Thank you all for being here today. Really appreciate it. Sunny, I know that you're going to be kicking things off, so I'm going to put myself on mute and let you get right to it.
Thank you, Charlene. Hi, everyone. I'm Sunny. I would like to thank you all for taking the time to attend this webinar. I am a co-founder and president of ProfitStore. We are a Red Hat certified partner. And today we're going to talk about our solution, Federator.ai, and how the solution addresses the challenging problem of resource and cost management for applications running on Red Hat OpenShift platform, and in general, any Kubernetes platform. And with that, I want to first turn to Cody, the Global Partner Solutions Architect at Red Hat, to talk about the important or challenging problem of cost management. Cody, please.
Thanks, Sunny. As he mentioned, I am the Partner Solutions Architect at Red Hat. I cover our ProfitStore and Federator.ai partnership. And I just want to talk about kind of what Red Hat has noticed, and as you can see by the charts on here, what other companies have noticed. So both these charts are pulled from the 2020 Flexera State of the Cloud report, and they both kind of tell a very similar story in that a lot of current public and private cloud users are noticing a huge amount of wasted spend. Based off the areas that are outlined in red here, you can see that optimization spend is the top cloud initiative for the 4th year running. So this is not a new issue that is being noticed. You can also see that there's about 30% of cloud spend that is wasted by companies. And again, that was 750 different enterprises that were surveyed. Then you can also see that 77% of organizations use cost efficiency and savings to measure their cloud progress. So between those last 2 statements, we have noticed that there's a huge amount of cloud waste, and a huge amount of corporations and enterprises are using that metric to see how efficiently they're using their cloud. And so with those in mind, Red Hat has taken the initiative to partner with companies like ProfitStore to understand and to help our customers after they deploy a platform like OpenShift or any Kubernetes solution. And so by using ProfitStore and Federator.ai, we're able to help our customers, partners, whomever is using Red Hat's technology to be more efficient and to help reduce that cloud waste. I'll pass it back to Sunny now.
All right, thank you, Cody. So let me really start talking about our solution, Federator.ai. The way you should think about it is our solution is really a tool for you to optimize your hybrid cloud. And if you take a look at the leading hybrid cloud platform, Red Hat OpenShift, you can think about us as the AI, artificial intelligence tools Federator.ai plus Red Hat OpenShift is really a hybrid cloud optimization solution. And the optimization is with respect to the resource in your cloud, the application performance, and cost savings. And this applies to private cloud, public cloud, or any infrastructure as long as you're running OpenShift. And now it also applies to even 5G network, because now 5G is running on top of Kubernetes. And just with like any other AI or machine learning tools, you will need to analyze the workloads, the application workloads. And based on your application workload, our AI engine will do a prediction. And then using the prediction of your workload will come up with the right amount of resources at the right time in order to support your workload. That's what we mean by optimization. No more, no less. And all these will need to be done autonomously. And that's really the key. Think about major enterprises running hundreds or even thousands of applications. It will be impossible for any IT administrator or DevOps team to understand exactly what resources are needed to support their highly dynamic application workload. And that's why our tool, Federator.ai, can help address that in an autonomous way. Let me just talk about a few customer pain points. First, customers using our tool usually encounter what we call the capacity planning issue, meaning that for the applications, they need to plan for the resources that are needed to support them, right, in order to avoid excessive over provisioning or under provisioning of the resources. Right? If you over provision a lot, that means you're wasting a lot of your resources. And if you're under provision, then you might not be able to run your application at the service level you want, and sometimes you might even crash. The second point is for some of the mission critical applications, you want to make sure you have really a performance assurance. So meaning that you want to understand whether there are enough resources to achieve the performance goal. The third one is clearly automation. As I mentioned earlier, in today's many hybrid cloud or Kubernetes cluster, even on OpenShift platform, many users have problem in understanding how they should configure the right amount of resources for each of their hundreds of applications. And finally, for users migrating from the on-premise infrastructure to a multi-cloud, whether it is Amazon, Google, or Microsoft, they want to understand what is the best multi-cloud or hybrid cloud strategy from a cost perspective. And again, I want to emphasize that all the above pain points will need to be addressed autonomously at scale. If we're talking about only a few applications, perhaps you can, by experience, fine-tune them yourself. But if you're talking about hundreds of applications, and each with very highly dynamic workloads, then you will need some kind of automation. And that's how our Federator.ai solution will help address these problems. Okay. So just to summarize, the value propositions and differentiation of our Federator.ai solution is that we use advanced machine learning or AI tools to help customers do a very intelligent resource planning that will help them optimize the cost of operation and resource utilization, and what we call using just-in-time feeder resource provisioning. With that, we can also accelerate or maximize your application performance with a predictive and proactive solution without any requirement on changing application code. And as I mentioned earlier, that our tool can also help enterprise users to determine the best cloud instance from different cloud providers for supporting their application. And by talking to many of our customers and partners, right, we believe that we are the only solution provider, partners of Red Hat, that delivering all the above features on OpenShift. And our solutions that is enterprise ready. We are one of the first early partners that are available on the Red Hat Marketplace. So if you go to Red Hat Marketplace, you will see our solution being there. We are also one of the early fully certified level 5 operators running on OpenShift. And our solution is also backward compatible with the earlier version of OpenShift, like 3.11. And in addition, we also work with other partners, other commercial monitoring solution provider like Datadog, which is also a Red Hat certified partner. Next, I want to bring up a specific customer and then describe the use case so that you have a better understanding of how a solution works and what the value propositions are. Right? Orange France is the largest telecom operator in France and fourth largest in Europe. They deploys our tool, Federator.ai, and helps them automate the resource management and optimizing the cost and resources on their multi-cloud. And specifically, they have a cloud team that is responsible for supporting many different DevOps projects within the company. And this cloud team, we need to manage resources and monitor the workloads for each of the individual projects. And there are hundreds of such applications running in the cloud. This cloud team wants to help the operation team to anticipate and manage the resources efficiently and reduce the operational costs. Previously, without our solution, they have to rely on the over-provisioning of resources. Like there's too many of them, too many of the applications. And to make sure all the mission-critical applications can run with the performance. With our tool, they also need to address and to automate the pod resource scheduling process, in particular on the auto scaling of the resources on the Kubernetes platform. By using our solution, now they have a clear understanding of resources needed for each of the application, different levels. We can talk about each project or each cluster. And so as to eliminate the need for excessive over-provisioning. And their conclusion is, on the average, they save about 35% of the cloud resources, which is really a big deal for a very large cluster used like in Orange France. In addition, in many of the applications, we can also help them improve the performance with respect to, for example, latency. Right, some applications we can help improve about 20%, and for some other application like Chapter, we can help them improve up even 80%. By using our solution, that will also help them save lots of manual configuration time and avoiding manual mistakes. And obviously, the larger the cluster size, the higher is the return on investment in using our solution. Just imagine about 35% of savings on your cloud resources. Okay, so I'm later on, my colleague Ming is going to give the audience a live demo of our solution. But here, let me just explain what you're going to see with Ming's demo. Right here is a typical UI of the workload from one of our customers. Right on the left-hand side, you can see that the white solid curve represent the actual workload of our customer, right? The CPU utilization of the application workload. And the green dotted line represent our prediction using Federator.ai. And toward the last couple of straight green solid line represent the recommendation after we observe the actual application workload, and then come up with our prediction, the green dotted line, right? And with this prediction of the workload, we can come up with the CPU limit. That is a recommendation of how much CPU resource you need in order to support your workload. And the right-hand side, similarly, in addition to CPU resources, we can also predict the memory resources needed to support your application. So again, the white line represents the CPU utilization, and the green dotted line represent our prediction. And toward the end is the memory recommendation in order to support this particular user workload with respect to the memory. Okay, so this is the resource planning or capacity planning that many of our customers will need, okay? And Ming is going to show you here, I'm just showing you that we can do it on the per application level. It can be done on the per project level, per namespace level, or even per cluster level. And I mentioned earlier, besides using the OpenShift, the Prometheus, which is collecting all the metrics for us, we also work with other commercial tools, monitoring tools like Datadog, which are also a Red Hat certified partner, right? Here you can see that the different time scale, you can do your workload or resource prediction per workload for the next 24 hours, or next 7 days, or even over a longer period, like for the next coming month. You want to understand what resources needed. So to highlight the area showing what the CPU resources needed for different time scale, as well as the memory resources needed. Besides the resource planning part, one of the most important features in Kubernetes or OpenShift is the ability to be able to auto-scale the resources. It turns out that the native horizontal pod auto-scaling, the HPA mechanism of Kubernetes, with very simple metric, they usually use CPU utilization or memory utilization, not that effective. First of all, without going into much detail, the native HPA outcome is reactive. It doesn't take advantage of the understanding of the application workload, right, or the application purpose. It tries to adjust the resources based on your current observation of the workload. And the second thing is, different application will need to have different metrics for the workload, and they have different performance index, right? In addition to just CPU or memory utilization. And the auto-scaling needs to meet the resource and performance goals, which the native Kubernetes HPA cannot meet that. And we have a lot of benchmarks showing that. And in our case, since we use very advanced machine learning technologies, we take advantage of the workload characteristics, understanding of the user workload, and do a pretty good prediction to achieve the performance goals, the resource goals. Okay, so new pod resources or replicas are being brought up in time, just in time, to address the performance requirement. And if your workload becomes lower, gradually lower, then these pod resources or replicas could be removed to reduce the cost. And when to increase these replicas or to reduce replicas to reduce the resources, right, are really our require some really advanced algorithms. And we take advantage, we have fine-tuned many of our machine learning algorithms to achieve that. So this is a screenshot showing that how we do the optimized auto-scaling. The scaling is based on the continuous workload prediction, right? So it's not done only once, a couple of hours. It's done really every few minutes, because the auto-scaling has to be done every few minutes to respond to any surge or sudden drop in your workload, right? So that you don't waste too much resource. On the other hand, you don't want to under-provision your resources in order to achieve certain performance goals. And here on the left-hand side, we show that what we recommend, there should be 6 replicas, and it executes 6 replicas to support the workload. And it also show that there's a minimum at least 1 replica, consumer replica, and there's a maximum of 8 replicas. And by the way, this application we're showing is really a typical Kafka workload, and we are scaling the consumer resources for the Kafka cluster. All right, and the user can set, right, what's the maximum consumer replica for the Kafka cluster they want to limit, and then within this limit, our AI algorithm will tune it to make sure that it is the resources assigned at the right amount of resources. And lastly, let me talk about the one very important feature in our solution is typically customer would like to know where the money is spent, right, in terms of our resources. And they also want to understand what is really the resource cost per application or per project. And then with this understanding, they also want to know if they really want to go to the public cloud and run the application on one of the public cloud providers, what is the right or the correct instance type they want to use to support the best price performance. And also they want to understand which application in the cluster are taking up most of the resources or costs, right? Where's the bottleneck? And that they also want to understand if they're going to run the application on a public cloud provider, which provider has the best cost structure for them, right? So these are all the questions in general that our enterprise users like to understand or answer. And by machine learning of the enterprise workload, right, we're able to come up with a solution that help them optimize the cost. In this example, on the very left-hand side, this is an example workload, an example choice by the enterprise users on the instance side. If you go to Amazon, for example, AWS, right, there could be so many thousands of different combinations, different choice of instance type, right? And usually our enterprise customer will just have to guess what they will need based on the experience on supporting the workload. Right? And by running our tools on the existing workload, understanding it, we come up with a much better instance in this example. For example, we can come up with an instance type which only costs $1,000, $1,036 in particular, instead of the original choice by the enterprise users, which cost them a lot more. In this case, $27.41, right? And so forth. We can also come up with a instance from Microsoft Azure, which costs them a little bit more than Google in this case. And then another instance from Amazon, which is in about $1,500. And I'm not saying that in this case, it is always the case that Amazon is more expensive, and actually we have many other cases Amazon could be much lower. So it really depends on the application workload and what the parameters, the choices of the users, where they want to run the application. Sometimes in a particular country, some cloud provider will have more expensive instance, vice versa. Okay. And just to summarize, How our solution help our enterprise users. The first thing is resource planning. That's a very typical use case. They want to understand how to configure the resources, how to plan for the resources to support the application, so that they won't waste too much of the resources, yet they want to guarantee performance. The second thing is they want to turn on the auto-scaling, and our Federator.ai solution can do a much better job than the native auto-scaling feature of Kubernetes. The third thing, of course, is performance improvement, right? Given the same resources, how you can tune your performance, how do you scale, how do you schedule the resources. And so in certain case I mentioned earlier, it could be 20%, it could be 80%. In general, compared with native HPA, it is, in many cases, we see up to 6% performance improvement, right? And this is what we call application-aware decision making, right? Because our AI algorithm will learn about your application, your workload, your characteristics, and therefore we can do a much better job in optimizing the performance as well as the resources. And in the case of Kafka, the one I showed you earlier, we can do a much better job in reducing the consumer lag, meaning the latency of the Kafka application. And the fourth one I just mentioned earlier is the cost analysis. We're able to find the best cloud instance and configuration to support an enterprise application workload. And then we also have integrated and customized dashboard that will fit the dock, and we're also working on other commercial monitoring tools as well. And with that, I want to turn it to my colleague Ming to show a live demo of how our solution works.
Great, thank you, Sunny. Can you pass the control to me?
Yep.
Okay. All right, let me bring it up. Okay, yes, my name is Ming Xu. I'm the Executive Vice President of Product at ProfitStore, and I'm very happy today to show you a live demo of our product, Federator.ai. And this is the software that's installed running on top of OpenShift. We support multiple versions of the OpenShift release. And the demo I'm going to show you today going through some of the highlights of our feature set, and then you can see what the value we can provide for the customers. And here, this page is the first initial dashboard. Upon logging in, basically showing the basic information such as the cluster, the status of the cluster, what you have, and also show you the application that you have decided to monitor in your cluster, and that provide you the predictions of the workload in terms of the CPU and memory, and the observed value and predictions. So the dashboard here gives you some high-level information, but the most interesting thing is actually looking at the more detail on the workload prediction and how it can help you to do the planning. So over here, first of all, we monitor many layers of resources inside a cluster. And it's just not looking at certain applications, but we're looking at, for example, over here, show you the cluster level. And in this daily predictions, you can see the what's in the past few days, the last 7 days, the observation and the predictions, and then show you how roughly matching the CPU utilization. And over here on the memory side, you can see the memory use go up and down for the whole entire cluster. And then the predicted value, and look ahead, what would the memory or CPU usage look like? And this solid line, basically over here, is the recommendation that we think about what's appropriate resources allocated for the entire cluster. Now, of course, all of this depends on how you're going to utilize this information. We do have RESTful API allow you to query, in this example, this cluster, what is the my workload prediction, how much CPU memory are going to be used in the next 24 hours, or the next 7 days, or the next month. And these are all done by so-called the prediction window here. Even on the UI, we can see that as well. And that's to show you the different kind of the scale that we can do. And so this allows you to look at a different type of the prediction window you're looking at. Other than the cluster level, we also can look into the namespace, right? For example, this is the namespace level, how you're going to use this throughout the time, what's the recommendation. And so this is actually provide different levels of the resource usages for all the things that you're interested in. After installing the Federator.ai and point to a cluster that you are interested in monitoring and doing the prediction, all the namespaces inside the cluster are automatically being monitored and predicted. So below the namespace level, we can actually look at the application levels. By application here, we are looking at more specific that you define and might have several different deployments or stateful sets or different controllers for that matter. Of course, in my example over here for this Kafka application, I only have a Kafka consumer as my workload prediction on the CPU memory usage. And then you can actually, define multiple different applications that can allow you to share how many number of the pods containers currently are here, and what your prediction is going to look like. And this is, in terms of planning side, as I mentioned before, important is to be able to automatically to get the information and adjust your memory usage or the CPU usage request. Then, using our API is the best way to get the information and then use that as the recommendation to adjust the CPU memory based on what your planning schedule. So that's kind of things that we provide for our customers to be able to use that. So this is the workload prediction area. And we not just only can monitor one cluster. You actually, in my example over here, of course, I only have one cluster, but basically you can actually choose multiple different clusters, so you can simultaneously monitor resources used by different clusters and by different applications. And the next one I want to talk about is show you is, kind of get into a little bit detail of our auto scaling, right? Sometimes, yes, you see we can do the workload prediction, we know how things can be used. How do we automatically scale up the resource to fit the demand of the workload so that you can keep your performance goal? And of course, right, there is the native HPA by Kubernetes, is based by certain kind of the, for example, CPU utilization as your target, and you let the system to run that for you, right? There is a question, actually, I saw somebody asking, why do we think the HPA in Kubernetes need to be application aware? I'm going to use this as an example to explain why more than just using the native HPA and try to scale the Kafka consumer in this case. If you look at the how the Kafka system is working, you have producers that produce the messages sending to the brokers, and then you have the consumer based on the topic and consumer group that is going to take the message out from the message queue and process it, and then try to do this as much as possible. So if you just look at consumer, you hopefully say, hey, when there are a lot of the messages stay inside a queue, then you do want to inside a broker, you do want to consume it as quick as possible. And sometimes 1 or 2 container or pods for the consumer is not enough. You need to bring more in to help you to consume those and process those messages quickly. But that itself not necessarily going to look at the CPU of the consumer itself to decide, yes, this is be able to handle the load. In our own benchmark, we actually find out that if you're using an HPA, using a CPU utilization, first of all, you have to think about what is the right target you can set that will make it useful for you. In our example, in our benchmark example, we find out that even to find a good CPU target, CPU utilization target as your indicator of workload, it's a guessing game. You have to try many different times, try to see about which one actually give you a better result. In some cases, if you set out the wrong CPU utilization target, you end up that you keep thinking about, I need to bring it down because my CPU utilization is not there. The operation is more I/O bound than the CPU bound. So you keep reducing the CPU, reducing the replica. So we believe in our testing, the way to look at what's the best indicator is the arrival of the message, what we call the production rate. And in conjunction of our workload prediction, we can look at the how many messages coming in the next few minutes, and then accordingly bring up the replica, try to address that. And the performance key, some of the performance KPI for this is, you want to make sure your consumer lag is not a lot, because that means consumer lag is how many messages either stay inside of broker queues have not been processed yet. So the whole idea is try to reduce the consumer lag, reduce the latency, so we can process as fast as possible. And you can see from this, current this diagram over here, this chart, you can say that on the right-hand side, you can see the workload go up and down based on the message arrival, right? So you go up, go to the 1 million, coming down, going up and down. And we do this based on, together with the workload prediction we do, and also look at the other metrics. The scale of the replica number go up and down. And this will also try to address the workload coming. And we find out that with this kind of application-aware auto-scaling with the workload prediction together, and the behind the scene, some modeling that we could actually find out what's the best recommended replica, and then scale the consumer income based on that. And compared to the HPA, native HPA we do, we find out that we can use in the same type of the workload. And that means it is the better resource reduction while maintaining the same performance goal you have. So this is the one we believe that is going to really help with application awareness, choosing the right metrics for the workload, and with the workload prediction that can give you the best options. Next, I want to really go back to the what we talked about the multi-clouds earlier from the presentation. As mentioned before, in this example over here, we have, let's say, you have current configuration. You have one master and 3 workers, right? And you have your instance types. And based on the current a configuration you have, your current running cost is about $27.41 per month. And we, based on your workload, based on how much you actually really use, and try to be using that prediction, try to give you the recommendation, say, if you are using, even with system AWS, you might have a different choice of the instance type that allow you to get to handle the workload you're going to have, but at the same time save you money. This is allow also, of course, also give you the Google Cloud, in Azure, similar kind of a workload with the right instance type we recommend and how much you can save. Now, user can, of course, choose different private options. So if you are choosing the reserve pricing is a lot cheaper, so you get more savings. If you are using on-demand, pricing options, and the prices are higher. And we also allow you to look at a different type of the region or country, different country, to look at if you want to set up your data center in the Canada, then what are the different options? And this is all part of our internal price calculation and allow you to look at different regions. One thing I also want to mention over here is, of course, right, it is also allow you to specifically, I'm only interested in AWS, right? And then we'll give you, so, okay, you will probably get the same price, but there are different regions you can consider, depends on your choice, right? So these are all the options that we allow the user. And if you go down to look at, what's the recommendation, okay? So based on your workload, you think about you only need one master and two worker nodes with this instance type. Should be able to handle the workload you have. And then your monthly cost will going to be only $14.18 instead of the $2,000 something. So this is one of our capability to allow you to look at how you save the cost if you choosing, even within the same provider, what's the best option for you to save the cost. Of course, we also not just say you have to be on the existing public cloud to be able to use this function. If you are in the current private cloud or your data center, we'll still look at your current current usage and your current configuration and give you recommendations. Right. And finally, I want to show about over here. Additionally, we do the cost analysis also based on the different namespace, for example. And over here, they show you clearly, you can see about your more than 70% of the time your system is in idle for the whole entire cluster. And you have a different projects, the different namespaces can show you how much your the cost consider the entire monthly bill you're paying, right? And then together with our prediction, we can also predict about the usage is going higher or lower, right? So this is allow you to look at what's my cost going to look like. And over here, this is an example over here. Starting from November 1st, you have several namespaces, how much they are spending the money, and what's the projection look like throughout the month. So this actually gives you a way of where the things are going. And this is being calculated frequently. So you can actually see the update, daily update, every hour you got new information come out and see where the price is going based on the information on the workload. Okay. So this is the cost allocation page that allows you to see, yes, you do have over provision, and you should be able to reduce that, for example, based on recommendation, reduce the number of nodes and look at it in the future that it can save you money. Right. But similarly, we also have the API allow you to do this query, so you can based on the recommendation of the instance types. And you can plan together with it and decide when do you want to bring up a new node, because workload is, it's getting very high. You are in danger of, running out of resources. or you can see that here, I'm not really seeing that I need that many different nodes. Maybe I can bring one node down or two based on recommendation to save you money. And all these are the way allow you to be able to automate the bring up and bring down of the nodes and based on the recommendation. Okay, so this is the end of my demo. I would like to say let's open up the question for in case people have questions to ask.
All right, great. We've gotten one or two questions in so far, so there's plenty of time if you have a question for any of our speakers. Let's go ahead and you can go ahead and use your GoToWebinar control panel, and let's go ahead and get started. Let's see. Okay, first question. What is the reason for the consumer lag?
Okay, so this is go back to our previous example over here on the Kafka. So consumer lag is actually an indicator of what is the how many messages still inside the Kafka broker queue that need to be processed. So if you have a lot of messages coming in and you are not processing quicker, the consumer lag will become bigger and bigger. And this is actually one of the key KPI that the people that are managing a Kafka system to look at. If you see about a consumer lag continue to increase, then you know you're not catching up the message will not be processed quick enough. And then you will get longer and longer, and then the costing system performance, customer, the end-to-end system response time to go low, and that will impact the customer experience for a lot of applications. So that's the reason you want to look at as a part of the application aware auto-scaling. You need to bring in some KPI that are really important for you to make decisions and with the workload prediction to look at how do you scale and hopefully to get your achieve KPI goal. Hope that I can this answer the question.
Okay, great. Let's see. Next question. How long does Federator.ai need to collect the data before making a prediction?
This is a very good question. It really depends on the what we call about the previous prediction window. That if it's daily or weekly or monthly, right? Now, for the daily prediction, right, we more frequently look at a sampling point. So usually within a few hours, you can start to see the prediction values coming out. But if you're looking at the monthly prediction, right? Since monthly we are looking at every day what's the usage look like, you need enough sampling point before you can produce that. So in other prediction window, it will take more time. But if you just install the Federator.ai and choose the application, or even just look at the cluster itself and look at a daily prediction, a few hours later, you will start to see the prediction already coming up.
All right, great. Next question. Besides Prometheus, does Federator.ai work with any other commercial monitoring tools on OpenShift?
Oh, yes, we do. Actually, we do have other than Prometheus, we do support and a good integration with Datadog. And as some of you might know, Datadog is one of the cloud-based APM company. They have a very good, successful customer story and has a lot of users. And we do a lot of integration with them. Here is actually one or two existing, dashboard that we do integration over here. This similar over here. This is what we call cluster over here. Inside this same cluster, we can do what our prediction is and what our recommendation for the next, 24 hours or next 30 days or next 7 days. And we also have, at the application level, the same thing. What are the prediction and what is the recommendation for, let's say, Nginx, this application. And also show them about the prediction values, daily, weekly, monthly, and roughly follow the usage, pattern, and we do the prediction. So these are the kind of integration that we do with Datadog.
Excellent. Okay, guys, there's plenty of time. If you have a question, go ahead and use your GoToWebinar control panel, and we have time for a couple more here. Next question, can we make changes to the properties on the dashboard if we need to?
For the current dashboard right now, the way you choose it is this. This is a little bit static, but there are very many different options that allow you to look at, the different prediction window, all the other stuff to do. Now, we are looking at how to make our UI more flexible for people to customize it with the dashboard, how to use that, and that's kind of in our plan to do that. At this moment, this is the UI interface, but for the other Datadog integration, now since Datadog itself is a very flexible way of doing the different dashboard, and we do all our information, all these recommendations, prediction value, all the things we have, you can see here already, uploaded to the Datadog cloud. So in a way, you can also customize your own view. If you are a Datadog customer, of course, then utilize our metrics that are provided up to Datadog can customize your own dashboard. But in the current UI, we are in the process of trying to enhance our UI to make it a more flexible way of people to customize their widgets.
Okay, excellent. All right, it looks like we all the questions that have come in so far. So we'll go ahead and, actually we just had another one come in. Haha. What do you suggest as the best optimization workflow for performance?
Okay, so the using our system, right? If you are in conjunction with what we have, you define the application, and then you're looking at the CPU resource and stuff. I think the workflow for doing that to be able to handle it, to auto-scaling that is, there's two parts of it, right? One is, I'm looking at a workload and there's recommended resource usage, and how do I adjust that to help me to handle my system. And using our API to PDI query about once a day or once a week, depends on how your planning goes. Based on those things, you can get the value and then plug it into your way of configuring the resources for your containers. And that will be one of the ways to automate that. If you're looking at some of the performance-based stuff that you want to look at, for auto-scaling, like what we had before, it's the same thing, is doing the API call to get the recommended part numbers, and that allow you to do the auto-scaling based on your own criteria. So these are the two different ways to use that for the optimizing for your usage for your application.
Excellent. Okay. So yes, so looks like those are all the questions we've received so far. I'll go ahead and leave the question and answer period kind of open while we see if any final questions come in. And while we're waiting, I just want to quickly remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar will also be living on the DevOps.com website. So you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, still no new questions in. So I did mention at the top of the hour that we would be doing a drawing for $100 Amazon gift cards. So why don't we go ahead and do that real quick. Today's gift card winners are Heidi B. Congratulations, Heidi. Second winner is Jake K. Congratulations, Jake. Third winner today is Richard F. Congratulations, Richard. And our final winner today is Tom L. Congratulations, Tom. We'll be following up with all four of you offline by email to get your Amazon gift card over to you. And please check your inbox. If you don't see something in your inbox about it, please check your spam folder. Okay, let's see. Yeah, it looks like we are all set on our question and answer period. I'm going to go ahead and close that out now. I do want to thank Sunny, Ming, and Cody for a great presentation today. Thank you so much for your time, your expertise, your demo. I'm a big fan of the demos, always have been. So love to see the technology in action. So thanks for that. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off now. Have a great day, everybody, and have a great weekend and stay safe.
Thank you, everyone.